Hello everyone. Sorry about yesterday's video. Literally was at a wedding and I had no internet, or more like no laptop to code. So it was a pretty shit video, but that's okay. We'll be back today with some more parsing stuff for Monkey program. Let's see if I can get through this. So we have the statement node stuff. The parsing stuff does get a little bit tricky, because it's getting a bit recursive, but it's not as terrible because the recursion isn't necessarily like calling itself. It's more like calling other functions. They call it recursive descent parsing. So like they try to, you basically boil it down into more, statements, until you hit like a absolute, like literal that you could just return out, and you keep doing it. So does that. But regardless, let's see. So this is my AST go. We should also make the expression node. Yeah, let's make our, first let's also make the identifier structure. Type identifier. Identifier. Struct. So we have a few things here. So an identifier is example like x equals 5 or like 5, right? The let statement is this entire thing, right? Struct, but the identifier is just this variable right here, right? Identifier, right? So that makes sense. So what does it have? It has obviously the identifier, right, which is a type of token, right? Token dot type or token. So it's like one of these right here, right? I need to fix my VM. I've been so lazy these days, so maybe I'll do it later today. Then we also have the literal, right, or the value, right, string. So then this identifier is still a node, and identifier is in Monkey are expressions. So that is something we need to do. So func I points to the identifier. Call this the expression node. Right, implements this. Also, by the way, I got new switches. I don't know if you guys can tell now. It's a lot. I got these nocturnal 20-gram linear switches. They are super light. So yeah, they're super light and super quiet. Reason for the switch, I don't know. I just wanted new switches. And then the tactile, I think they were a bit too loud. I always take these to school as well, so we also need to implement the token literal, because these are all node types, right? I think. Yeah. These are all nodes. So all of these are nodes, so yeah. So that's cool. Return dot I dot token dot literal token. Why is it a string? I don't know. What is the type? Yeah, it's a string. So that's nice. We'll fill these out soon. So the basic structure is we have the program, right? So like this is a type of program, and a program is just a collections or a series of statements. Statements are they have, for a specific one example is a let statement, right? Is it just this, right? So identifier let statement. So let statement is broken down into two things: a name. So okay, the let statement is the statement itself. So we get the token, right? Which is the token dot I think let, yeah. So that's its value. So what is a let statement? It is in a collection. It's a field. The fields are going to be the name itself, which is a special type of type. It's just the identifier, which is the name of the thing, right? When we say let equals x, let x equals 5, right? The x is the identifier for that let statement. The value is an expression, right? Now, expressions can be many things. Something that can be a value. So it could be just a number itself, a 5 times 5, or it could be add 5, 5 divided by 2 times 4 plus 6. This could be could be on the right side of the let statement, right? This is a valid let statement, right? Right. This right hand side right next to it is there. So that is an example of a expression. These something that produces values. Statements are just, they don't produce anything. They're just like, they just like return 5. That's a statement. Doesn't produce anything. Let statements. I don't know about if statements. I think in Monkey the design choice might be that if they're if expressions. I don't know. I think it might be if statements. I don't know. We'll see. But that's the basic distinction right now. So all of this is part of the AST class or AST file, and yeah. So let's actually make our parser. So we need to import a few things, right? We need to import the boot Noah / the AST, or the monkey / AST. We need to import just the three things: the AST, the token. We need the then we need the Lexer as well, of course. So we need all three of these, right? So let's make the parser. So the parser has 3 fields, right? So the parser has type parser, struct, okay. I need to figure out a beta, like, I have this like Vim habit to put both of the brackets, but I always suck at doing this. Like, I press I or A and then put that there, escape, press I again, or yeah, I just need to get better at that. I don't know why I can't do that. Let me try again. So like I said, struct, right? Okay, yeah, I see the issue now. So it's like struct. Yeah, I have to press shift though to go above the line. And I want to do that really fast, but I suck at it. Struct. When I see the issue, it's struct. I sometimes press this weird mod key. Try if I do it fast. Struct. Whatever. I'm just getting sidetracked. So we have the Lexer, which is the Lexer dot Lexer. Right. We have parser needs. Okay, we need the current token. Token. Like that is the token that is in examination, which is similar to the logic we have here. In the Lexer we have, right? We have the position and reposition. So that is a similar logic. We want to know this and the next, right? So we need to implement a few functions for this struct. I don't know what do we need. We need a few things. It's like initializer. We'll make a new function for it. It returns a pointer to a parser, and it will initialize this two pointer. So remember, like we'll have like a token, right? Like token 1, token 2. We have the C pointer and the N pointer. It's going to be initialized to this, but right now they're null, so we need to set them up. So let's make the initializer. So this is the P pointer to the parser. We have new, yeah. So it doesn't take anything. What is it going to return? A pointer to a parser. And it will return P. But what is P? P is a new lexer. Well, a parser that takes a lexer, lexer dot I don't know. How do I make a new thing? Well, actually, this is not part of the class, the struct. This should be, since it's going to be that, it takes in a pointer, which is a lexer dot lexer, which is that type, right? Then we just say L. So that is the thing. So it takes in a lexer, right? Okay, remember we're not restoring and the whole thing. We're restoring the address since we're returning a pointer. We point to the same instance, and then so the part. Okay, my fault. It's not part of the struct. It's not part of anything. It's what the user exposes. This is what the user should be exposed to, which is a lexer. Regardless, I want to do a few things, right? I want to do p dot next token and do that. And let's now make things that are associated with it. Parser next token. It won't return anything, but it will advance the pointers. It will say p dot current token, right, is equal to next token. I think that's valid, right? And is the L dot, well, it's not current, right? This is next token, right? So we have access to the lexer, so p dot l dot the token. So how do I get the current token? What does it have? So we don't rechar. Oh, is it next token? What would be the thing? Parser, go. I'm missing something, man. I'm missing something. What is the next value? Like, how do I get the token? Is there a function? Next token. Oh yeah, it's fucking this shit. We've been working on the past freaking thing, you know? What am I doing? There you go. Okay. Why is it not liking this? Next token. Oh, what is it? It doesn't return anything though. Oh, I see. I see the issue. We should actually call this peak token, right? Because just grammatically, peak. This is what it is. It's not really. I mean, well, it doesn't matter what I call it, but I think peak token makes more sense. Peak token. Yeah, let's call it like that. Because I already had next token. I think I was getting confused with the function name and stuff. But I think, yeah, we're good here. This is the initializes, so now it's gonna be 2 tokens at a time. And yeah, we're gonna do the parse program, which is the biggest thing. Which is the biggest thing to do. So p dot parser parse program, right? Return nil for now. Well, it actually returns an AST dot program, right? Which is this thing here, right? A program is a collection of statements, and a statement is I see the vision now. Collection of statements. So like if statement, less. Well, I don't know how Monkey's gonna do it, but the most basic thing I can think of is just like less statement, right? There might be more statements, which is like return statements, right? So it's a collection of those, and then statements can be built up with expressions, but not necessarily sometimes, you know. Regardless, yeah. So statement and expression. I don't know. So let's go back here. I'm gonna make a parser test.go. I like how like Go has a package parser. Import testing. We'll be doing some testing for sure because CD parser. So yeah. So we have a bunch of stuff to kind of test, right? Before we write this, as the test-driven aspect of it is to test the parser and AST. We're also gonna need the git. Okay, I'm not writing that again. I kind of regret it, yanking this, making this long. Well, I don't need this. I need this. Okay, I'm a dumbass that does not know how to use. Oh my god. There you go. Let's put these together. Okay, not AST. I needed parser. Wait, what did I need actually? AST and lecture. Oh, the lecture. I'm already in the directory. I don't need to input that. So yeah, let's do this. Funk test let statements t dot testing whoopsie T dot testing. Yeah. Oh, what is it? Testing? Oh yeah. The module testing, right? Testing dot T. I should really look into the documentation here. It's super cool. Yeah, we're testing light statements. So let's see this. Input. So it's gonna be similar to the lecture. I'll do something like this, you know. But I need to change in quotes. Let's do this. So if we're testing light statements, we gotta do let equals x. Let x equals 10. Let's do y. Add. We also want to add the function too. Fn. It's gonna ignore it because that's not what we're testing for. Oh, actually, okay. I don't think it actually tests that. Let's do this. Let foo bar equals some big ass number, you know. Alright, so what are we testing for? We want to basically be able to break these down, you know? I want to be able to test that out, so... But anyways, you know, what I like about Go's thing is the import system. I thought it was a bit confusing at first, but my goodness, it is so much better than JavaScript, because JavaScript shit is like weird sometimes, especially with like the alias stuff. So we have the lexer.lex. I think we have a new function, so yeah, we just say new. Oh, new takes an input, right? And then we do this. We pass the lexer in the parser. I guess we could just call p equals new, right? So we have parser for parser, and well, passing the lexer. Do we put the address of it? Because it takes I forget what this takes. I don't know. Oh, yeah, it just takes the thing. Very nice. Then we will program. So we'll do the stuff here. So we'll call this thing here, right? Parse program. Right? P dot parse program. Boom, boom, and for something, do it forever, right? That's not true. So we have this. So we have if program if program equals token dot eof, right? Or nil. Oh, I see. Nil. This is what it's doing. I see. This is the thing. So if it's nil, then t dot fatal f parse program return it nil, and then let's do some other checks, right? What are we checking for? If the length of, okay, that's true. If length of program dot, so if it's an AS tree, it's the program does not equal 3, right? Wait, what is the array that we check for? Oh, it's statements, not program, but statements. T dot, we do something like this. Parse program. Well, I don't know what to say for this. Program estimates does not contain 3 statements. Got this. Yeah, okay, got %d. Okay. Program does not contain 3 statements. Got %d, and we could say length of program dot statements. Oh god. Anyways, that's really nice. So regardless, we can now do our tests, right? Which is, I think, similar to this, right? Test, which is like an array of structs, and we'll, or like struct, right? And we can type it as expected token string, I guess, and then we'll just make a bunch of them. Right, or not token, identifier, right? Expected identifier. Fire. Did I spell this right? I don't know. Boom, boom, boom. X. Foo bar. So these are the expected ones. Makes sense. Like, we're just like getting these through, and then we haven't done. I don't think we're gonna do the. We'll get to that point too. But anyways, so Tesla estimates. Right. So for every t, or I guess index I and tt, range from tests. My god, I hate this so much. Okay, so when I say test, boom, escape, go down, push this in, escape up here. Statement equals tt dot program dot statements. I going through this, then we say if not, I guess, test let statement. Right, if not, right, then we also gotta make this function here. Func. I think it returns a boolean, and it will take t testing t dot t. It will take well, actually takes a lot more than this. So yeah, let's pass in the t. I think some AST stuff, right? So like the statement itself, which is the AST.statement, or yeah, statement, and the name, which is the string. So name string. So statement and tt dot, okay. Expect, so we got this here. Oops. So we have this right here. Oh my god, no. So yeah. So how do we do this? Test less statement. So what needs to be true? So if the, I guess, s dot literal. Well, okay, I forget what this has. AST dot statement. What is a statement? It's a node. So yeah. Token literal does not equal name. We have to do something, right? Well, not necessarily name. It's okay. I see the name. If it's not a let first, that's bad, right? Then t dot fatal l. Well, I don't know. I keep forgetting the logging stuff. Ugh. Well, this is wrong. This needs to be oh yeah. This is not a let statement, so s dot token literal is not a let statement. So God. Literal. Oh, let me maybe close this off. Yeah. So that's the first thing. Now this is a weird syntax. S dot AST dot let statement. Do we have access to that? Let statement. Ah. Oh, I see. It's not. It's checking for. Is it a type of let statement? I see. Parser go. Oh, I have it here. So yeah, if this is checking for, I believe. Well, if we pass all these checks, return true. It's also it's checking if it's a type of if let statement, right, is if I do s dot, and this is doing some weird syntax here, let statement, this is checking for, is it a type, like, right? If not, okay, right? If not, okay, we just take one of these, place that here. Change a quote. We say not a let statement node, right? So kind of what we're saying. Yeah, the type, or I guess error. S, I guess, changing quote. S is not a AST.let statement. It's not a type of a let statement. It's not the correct type. So we say got type, and then we can just say let. Right? That's what we gotta return false. I think that makes sense. We're just testing for if this is the right, like if S we get here, right, is not this type here. Like we need to make sure it is a this type of node. If it's not, bad sign. Something we want, right? Obviously, so. Now we can get kind of the. Well, okay. Oh wait, that makes more sense. Let's put S instead. Does this like get me the value or something? Like, does this get me the struct we're supposed to get or something? Oh, it's just generic. Does statement compose of let statements? Let statement. I'm confused now. AST.statements. Oh yeah. So we're getting. Oh, I see. So we implement the statement inverse. That's why it's that type. And then we get the actual statement that this implements. So now we have the actual values associated with the statement. Because I think the parent struct didn't have it. So let statement. So we can say so if let statement dot name dot value, right, does not equal name, right, meaning the identifier like x, y, foobar, then we want to also log fatal, do something else, right? So we can say let statement dot name it's not a it's not does not equal I don't know what to say this. It's not got guys. So we have so we let statement dot name dot value. We got this but should have gotten name. The last checks we're doing is the token dot literal. It's literally the same logic. The let statement dot value, I guess name dot token literal, then token literal. It's not equal. Let's call this token. There's more test cases, but I don't think that really matters. Now we need to write the parse program. So oops. So let's do this. So return the AST program node. Well, not node. Well, actually, program. Never mind. So program AST dot program, right? I mean, not program. This create a struct, right? Or not struct, like an array. Then program dot. Well, this is the array actually. Statements equals the the AST of program. Well, I'm not assigning this, so there's that. Why is this bugging out? Go mod tidy. State. So why is this not valid? AST.program. Oh. This is AST statements. Duh. So while the p.cur token does not equal token.eof, right? Oh well, this bad type, right? The current token.type, because what does a token have? Type, yeah. Then we need to do some stuff. If p.current token dot type equals token dot let I guess we could do like statement like this. Yeah, statement p dot parse parse statement. We haven't made that function yet, so but I guess we could say statement equals p dot parse let statement, something like that, right? Oh wait, am I doing this wrong? Oh, this is not what we're supposed to do. I got mixed up. Right. Parse statement. If statement does not equal nil, program dot statement append program dot statements. And then p dot next. I hate this. What am I doing? Next token. Now I need to make that function, right? Parser, parse statement. Right? What does this do? Right, P. Right. So what do we do here? Obviously returns a ast.program. Switch p dot. Oh, we have switch p dot cur token dot type equal well, there's a bunch of types, so we have case token dot let. Well, default return no. Return p dot parse let statement. This is the weird recursive trailing. It's not really recursive, it's like calling more functions, but statement. Yeah, we gotta freaking make that now. One of these joins. Parse let statement. That returns a pointer this time to let statements. Let statements right here. I see the vision now. Like we kind of like, okay, detect it. So we detected a statement. It's a let statement. Now let's make the let statement. So I see. And then return that by building it out as we see the token. Okay, so statement. This, right? We're saying let's build a thing. ast.let statement. So we have token. So we have, okay, inside the let statement, we have a token identifier, which is the current p.cur token, right? What do we need to do? If p.next peak token equal. Well, I can't say equal. I'm gonna say does not equal token dot eq. Return no. Peak token is not valid. Well, Yeah, why is this not valid? Oh, it's not a function. What am I saying? Expect peak. Okay, there. It makes a bunch of helper functions. Should I make those two? Expect peak. I guess he does it because there's a lot of bullet code to return. Okay. So we have three things, right? So, yeah. So it's okay. This is the wrong thing. I can't do this. I have to make a function. Well, I could, but like it's just cleaner to do it that way. So first is okay. It's a let statement. It's check if it's a identifier. So if not expect, I guess p dot expect peak, which is the token dot eq, right? The fuck am I doing? Right. Then return null. Once that is done, if the next not equal identifier, right? If it's not an identifier, then that's bad. So return out. If the expected token is not an assignment, right? Because the let statement has a few more things. The let token, the name. I'm gonna have this on hand, stamp away, because so we have the let tokens, we have name. So that's valid. So we don't need to do a check for this because we already come from a place of this, right? Right? So we come from a place of checking it. So now we just need to check for the name. So check the identifier. So that's if that's the case, then statement how do I add stuff? Oh yeah, statement.name equals the p dot current. Okay. So what does p have? P dot current token. Yeah, current token. Wait. Token. Wait. P dot turn. Oh, I make an identifier. I forgot about that. So I forget. So it's like okay, AST dot identifier, right? So what does that have? Identifier, yeah. I wish I had the thing. What is it again? AST, yeah, identifier. So we have this. Brother. Parser.go, give me the thing. Oh my god, I'm gonna die. Alright, so we have the name here, and it takes a token, which is how do I get the do I move on? Do I do p dot next token? Oh, I don't need to do that because the expect p actually moves me forward, so that's really nice. So yeah, that I can just do token p dot current token, and we need a few more things. We need the value, which is the p dot current token dot I guess we would say literal. Is that valid? No. What is it then? Oh, sorry. I have to say value. So that's valid. So yeah, then we do current is. There's another one called current token is. If not p dot cur token is token dot semicolon return nil and not return nil, just well, I guess I can return nil, but I have to I have to skip for this. Yeah, current token is then not semicolon, then p dot next token. So we just basically skip white space, and then return statement. Now I need to implement these dumb funky methods. So let's do func p dot parse or parser expect peak. We got t for token dot token and a boolean. We have another one here. Cur token is. So you need to do three function. Peak token is. It's like a wrapper function for this one here, which just say this. Peak token is return p dot current or peak token is if this one's a bit of a weird code style. It's like make another freaking wrapper, right? Is if p token, right? So let me just call this p dot that, and then t advance forward p dot next token return true, else return false. Okay, Let's try the tester. Go test this. So, okay. Let's see why. Oh, I see. We're not allowed to use these damn bullshits. Oh, didn't I import token? Oh, I see. I think it's a string that it takes. Correct? No, token type. Sorry. Type. It takes the type. Right? Are they all happy now? Oops, hold on, there's something issue. Oh, I didn't fucking implement it. The current token. Okay. I see. Who is crying? Because I can't still. Doesn't. Wow. Why can I not do this? Okay, it recognizes that. Recognizes this. Oh, wait, what? Oh, Lord. Why is Dix crying? Is parse let's even not part of the parser class? Maybe it's because I should do all of this above it. And still? What is... Okay, it knows it's there, but... So what is... Why are you crying? Token.let. Is it even also crying about this? Oh, I'm not supposed to return this program. We're supposed to return statement. Yeah, it makes more sense. Let's try now. Go test this. Awesome, guys. Anyways, that's it for today. Thanks for watching as always. Grind doesn't stop. Let me know what other types of videos you guys want to see. I'm gonna probably fix my Vim setup if you guys want a whole video on that. But anyways, thanks for watching. I'll see you for tomorrow's video. We're almost, real quick, we are almost at, what are we at actually? Almost 800 subscribers. I really appreciate it. So, you guys have been killing it with the follows and stuff, so thanks for watching. And I'll see you for tomorrow's. Peace.